So I thought I'd walk you through a couple of the problems for your homework for lesson 4.2 parallel and perpendicular lines. And I know that this is not due till Friday, and I will be there tomorrow. So we're going to check this tomorrow in class, but I wanted to make sure that we walked through some of the questions together so you have a good handle on things. So question number 1 says, it is known that segment ST is parallel to segment CD, whose endpoints are at C, -2, 1, and D, 4, 10. So let's just kind of draw a sketch. So this is segment CD. This is the ordered pair -2, 1, and this is the ordered pair 4, 10. This is point C and this is point D. So I have to calculate the slope, and then that will tell me what the slope of segment CD needs to be because they're parallel. So the slope of segment CD, well, y2, 10, minus y sub 1, 1, over x sub 2, 4, minus x sub 1, which is -2. So 10 minus 1 is 9, and 4 minus a -2 is a negative. 4 minus a -2 is a positive 6. And this can be reduced. 9 over 6 is the same thing as 3 over 2. You know that you need to remember you can put that into your calculator and it'll reduce the fraction for you. So we're looking for a segment that has a slope of 3/2. Looking for a segment that has a slope of 3/2. And that is answer choice number 2. Now I'm given 4 points and I'm told that AB is parallel. I'm being asked if AB is parallel to CD and I need to justify it. So I'm going to do that by, again, calculating the slope of segment AB. And if it's parallel to CD, that means their slopes are the same. So let's see, segment AB, the slope equals 13 minus 5 over 1 minus -3. Well, 13 minus 5 is 8. And 1 minus a negative, well, that becomes plus. 1 plus 3 is 4. So the slope, excuse me, I'm sorry, of AB is 8 divided by 4, which is 2. So now I'm going to check the slope of line CD. So the slope of segment CD, 5 minus 2 over 10 minus 4. Well, 5 minus 2 is 3, and 10 minus 4 is 6, and 3 over 6 is the same thing as 1/2. So the slope of line CD is 1/2. Those are not the same. 2 does not equal 1/2, so these are not parallel. So I'm going to let you do question number 3. It's just like the one that we just did, number 2. Question number 4 says each of the following represents the slope of a line, given the slope of a line that would be perpendicular with one of the given slope. So we're just finding the slope of the line that's perpendicular. So line A, or segment A, we'll say, has a slope of 5/2. So the perpendicular slope would be the opposite, which is negative, and the reciprocal, 2 over 5. Let's see. This next one has a slope of -3/4. So the perpendicular slope would be the opposite. Well, the opposite of a negative is a positive, and the reciprocal is 4 over 3. Okay, so finish doing that up for examples C, D, and E. So E doesn't have a little answer blank there. Question number 5, a line passes through points EF. Which of the following would be the slope of a line that's perpendicular to EF? So again, we need to find the slope of EF. So I have y sub 2, which is negative 2, minus y sub 1, which is 4, over x sub 2, which is 3, sorry, 3 minus x sub 1, which is negative 1, minus a negative turns into a great big plus. So I end up with negative 6 over 4, which reduces to negative 3 over 2. So the perpendicular slope of this, well, first of all, would be the opposite. So that means it's going to be a positive. And then the reciprocal. The reciprocal of 3 over 2 is 2 over 3. So we're looking for a line that has a slope of 2/3. So you're going to do the exact same. Actually, no, number 6 is a little bit different. I'll do number 6 with you. So a line segment whose endpoints are 3, 9, and 7K is perpendicular to another segment whose slope is 2. So this slope is perpendicular to this. So we need to figure out the slope of this line. And the only way that we can do that is to set it equal to the perpendicular of this. So what is the perpendicular slope of negative 2? Well, the perpendicular slope of negative 2, let's write it as a whole number, is the opposite. So that's going to be a positive number. And the reciprocal, 1/2. So when I set this up, I'm looking for a line that is going to have a slope of 1/2. So K minus 9 over 7 minus 3 has to equal 1 over 2. Let's simplify. I can't do anything with the K minus 9, but 7 minus 3 is 4. And that has to equal 1 over 2. All right, so now we can set up this is just a proportion. So we're going to solve this by doing cross multiply. So 4 times 1 is 4. And 2 times K minus 9 is just that, 2 times K minus 9. I need to distribute. So I get 4 equals 2K minus 18. I'm going to add 18 to both sides. So 22 equals 2K, which means that 11 equals K. So K is 11. Now the other way that you could have looked at this, some of you guys have very proportional kind of visual brains. So I'm going to rewrite this off to the side. K minus 9 over 4 equals 1 over 2. So you could have said to yourself, well, what do I do to the 4 to make it equal 2? And I have to have a multiplier. I multiply by 2. So I know that some number, and if I multiply by 2 on the bottom, I'd have to multiply by 2 on the top. So 2 over 4 is the same thing as 1/2. So now I can say to myself, well, what number minus 9 equals 2? What number minus 9 equals 2? And that told me that that number is 11. 11 minus 9 equals 2. All right. So for this number 7 and 8, you're just graphing those. And then you also have pages 9, or not pages, sorry, Page 5, questions 9, 10, and 11 to work on. Questions 9, 10, and 11. I'm going to do question 11 with you. Because it's about a right triangle. So the first thing that we're going to do is we're going to graph our ordered pairs. Ordered pair E is at -2, +7. Ordered pair F is at 7, -8. And ordered pair G is at -6, -3. So it's asking us if this is a right triangle. Yes or no? Well, if it's a right triangle, by looking at the picture, the grid helps. By looking at the picture, I can tell that the right angle needs to be right here. That's where the right angle should be. So how do I prove that this is a right triangle? Well, I have to show that segment EG is perpendicular to segment GF. Because remember that perpendicular lines intersect to form right angles. So let's find the slope of line EG, or segment EG. So let's see, G, -3, E, -7, over G, -6, E, -2. All right, -3 minus 7 is -10. And -6, well, let's see, this is minus a negative, which becomes plus. -6 plus 2 is -4. So when I simplify this, a negative divided by a negative is a positive, and I can divide both of these by 2, so I get 5/2. Now let's calculate the slope of line GF. So segment GF. I keep saying line, I'm sorry. So segment GF. So I always start with the second coordinate. So F, the y coordinate of F is -8 minus the y coordinate of G, which is -3, over the x coordinate of F minus the x coordinate of G, which is -6. So minus a negative, minus a negative. So I have -8 plus 3, which is -5. And 7 plus 6, which is 13. So do these two lines produce right angles? Do these two lines produce a right angle because they have perpendicular slopes? Well, no, they don't. They're not perpendicular. This line has a slope of up 5. 1, 2, 3, 4, 5 over 2. Up 1, 2, 3, 4, 5 over 2. This line has a slope of down 5 over 13. I didn't draw that one perfectly, but they're still not. They still don't. They're still not. Still not a right triangle. So yes or no? Well, no, because the slopes are not opposite reciprocals. Okay. So those are your hints for 4.2 homework.